All right, Unit 7 is a fun unit. It's kind of a tough unit here at the beginning. We're going to use some of our notation and thinking that we had back in Unit 3 when we did transformations and we would do rigid motions, translate and rotate and reflect and all that awesomeness. So some of that is going to rear its head today. That could be a good thing if you did well with that unit. That could be a struggle if you struggled with that unit. And so that's going to be the next couple class meetings. Lesson 1 and Lesson 2 are going to feel a lot like that Unit 3 from last semester. So I do advise that you go back and look through those. Today you're going to need to have a ruler and you're going to need to have graph paper if you want to get full credit on your notes. Again, these are required class materials back from August. Want to make sure that you have those, that you do well with that. The learner will be able to dilate figures and identify characteristics of dilations. Basically, a dilation is when you take something and you make it bigger or smaller. You make it grown or you make it shrink down, but it maintains its angles, it maintains proportional sides, and so it's just like kind of like a shrunk down or an enlarged version of the same idea. And so you need these materials for these next two class meetings, for 7-1 and for 7-2, so make sure that you've got those from August. Those supplies are still relevant. So what is a dilation? A dilation is basically when you take a shape and you either compress it by some scale factor, you shrink it down if that scale factor is a fraction, or you enlarge it if that scale factor is bigger than 1. And you have to have a center of dilation, and your image, your image is a result of that pre-image dimensions being multiplied by that multiplier, that scale factor, all right? Our corresponding angles are going to be congruent, so the angles at B are going to be the same, at A and A prime, at C and C prime are going to be the same, but also, and more importantly, this is going to be our focus in this lesson, is that our sides are proportional. All right, so the length of the new side AB, A prime, B prime, divided by the length of the original AB is going to be the same fraction as BC, B prime, C prime to BC, and A prime, C prime to AC. So those relationships, this is kind of the key to this unit, is understanding that our sides are going to be proportional. Now, the first thing that you should notice is that these proportions are fractions that are set equal to each other. So a proportion is when you have two fractions equal to each other. An extended proportion is when there are three or more fractions equal to each other. So this is going to require that we have an understanding of how fractions work. It will require an understanding of how proportions work using our Algebra 1, chapters 1 and 2. It's going to be really essential here. These segments, A prime and B prime, A prime, B prime, and AB, these segments are parallel. A prime, C prime, AC are parallel. B prime, C prime, and BC are also parallel to each other when we've done a dilation in the coordinate plane. So our first two lessons, we're going to be working in the coordinate plane. We're going to have a center of dilation, etc. This first part is going to require a ruler, and there's kind of two parts for doing these dilations. Our first method is to make sure that we can draw a connection from our center of dilation to our vertex, all right, to each of our 3 vertices or 4 vertices or 5 vertices, depending on the figure that we're dilating. And then we are going to mark a location. We're going to measure a location that is that far away from the center of dilation as it relates to the original point A, B, or C. So here are the steps by steps for how to do this. We're going to draw these rays that pass through the vertices. Then we're going to mark a point on those rays. That is, in this case, this is a scale factor of 1/2. That is half the distance here. So we'd measure that and we'd multiply by 1/2. All right? And that would mark where B prime goes, where A prime goes, where C prime goes, measuring half the distance, half the distance, half the distance, etc. If our scale factor was 3/4, we would, on this ray, we would measure 3/4 of that distance. So in order to measure 3/4 of that distance, you might need to multiply that distance by 3/4, right? We want to make sure that we can use our calculators to help us with that multiplication, to help us with that location for where these points are going to go. If our scale factor is bigger than 1, let's say it's 1 1/4, let's say it's 5/4, then we would mark a point that is 125% of that distance. So here is 1 whole, here is 1/4, and we would go an additional fourth on that, an additional fourth, an additional fourth. And that figure now would be 125% of the original size of this figure. So it's not a copy of the original, but we should see that it is a scaled down copy or a scaled up copy of our original pre-image, all right, how that gets us to our image. So keep in mind these relationships. This is going to be a huge part of doing this work, and it's going to help you see if you measured those well and correctly. Method 2 is where you simply mark the point, and if it's a scale factor that's bigger, you just want to double that distance. You just want to double that distance. You want to double that distance. You want to double that distance. And you don't have to draw those whole rays all the way through. But if you are making that figure a little bit larger, then you're going to want to follow through these steps as they are marked for us. All right. So with that in mind, let's go ahead and have this information down. Pause that so you can go on to the next slide and do that work. But what we want to do is, if we're able to do marking one of them, then we can make the other segments parallel to the first of the pre-images that we have. All right, so that's kind of a key aspect to all this, is using parallelism in method 2 or using measurements in method 1. Either way, you do have to do measurement for that first step. Actually, for second step, you know what I mean. We'll draw the rays first, and then we'll mark the distances second. So on this, method 1 is where we're going to measure each thing. This says dilate by a factor of 2. So for each one of these things, I'm going to get a meter stick so I can use centimeters. It's a little bit easier for me. You're going to draw these. Your pictures are going to look different than mine. All right, so you're going to do your best work on that. But for me, my measurement here, it looks like is, and let me do a better job here. This is 1, 2, 3, 4, 5 and a half centimeters. All right, from this point of dilation, from the center of dilation. I'm going to draw these rays through each of these vertices. Draw these rays through each of these vertices to the center of that dot and beyond, to the center of that dot and beyond. All right, and this, like I said, is 1, 2, 3, 4, 5 and a half. So doubling 5 and a half, 5 and a half times 2 is 11. So I'm going to go from the center of this through point K. I'm going to go 11 centimeters, so that's going to take me all the way down to this location here. Now this is on mine. This is not going to necessarily be the same on yours. So mine was 5 and a half. Yours is probably smaller, all right, because you're using a ruler, and I got this meter stick here. So I'm going to double that. This distance right here looks like it is about 13 3/4. Let's just say 13 and a half. So I'm going to measure out to 26. Is doubling 13. So if I measure this as 13, when I double it, I'm going to get to 26. That's L prime. This is K prime. And then over here for J prime, we are going to measure out how far is this. This one from the center to about there is, it looks like 11 and a half. So I'm going to go 11 and a quarter. So I'm going to go 22.5. So this is going to be 10, 22 and a half is going to take me all the way out to here. Now, when I connect these dots, this K prime, L prime, and J prime, I should get a figure that is twice as big as my original JKL. All of those points are located twice as far away from that center of dilation. All right? And so you can kind of tell in that regard that we did an okay job. Now, doing it in method 2, this is using parallel line segments, all right? So we're still going to have to do some measuring. We're still going to have to draw some of these figures. So I copied this. I drew this, or I copy and pasted the same picture. Method 2, I want you to be able to do a good job with this. All we have to do is measure one of those. And so I'm just going to measure that first one, and that first one, again, we said is about 5.5 centimeters. So I'm going to measure out, doubling 5.5 is going to be 11. That's going to take me to about here. Now from this point, this is all I need to measure. I just measure this one thing. But now I can draw segments that are parallel to our original drawing. And so again, the way to do that is to use the hash marks on your ruler. And we're going to do our best here. I'm going to draw that. All right, I don't need those, and I don't need these. That's not quite parallel, is it? I did something weird. Oh, I did perpendicular. Oh my gosh, I did perpendicular. I need to draw this parallel to that one. So if this one's going this way, then this one needs to be going that way. Let's try our best to draw parallel, Mr. Ibbott. Let's see how well we do. That looks pretty parallel. Again, you can probably do a better job than me on the parallel because you're working with smaller stuff. Here, this segment right here, we got to go parallel to that one, so I'm going to do my best to go through. It's not perfect, but we're going to give it our best shot. Don't move the ruler. All right, here is, that look parallel? That looks pretty parallel. It looks like I did a decent job. And then let's draw that one. Connect these should be parallel to our original. So there's L prime, K prime, and J prime. Get rid of those extra segments, extra segments, extra segments. Those look pretty close, right? Looks like we did a decent job of drawing the dilated factor using parallelism versus dilation using use measures on all vertices. All right, if you're using measures on all vertices, it's going to take you longer because you got to measure. Here, when you're using parallelism, you can just quickly draw those parallel segments. And obviously, do your best work, right? Do your best work. It should look parallel. If it's not looking parallel, erase it and draw it again. All right, now for these two, I want for you to try those. All right, this is two that you're doing, that you are doing, and these are shrunk down by a factor of 1/3. Now this point of dilation is outside of the figure, and so we're going to measure the distance and divide it by 3, and so that distance, instead of being this big, is going to be less than half. It's going to be 1/3. This distance is going to be not cut in half, but be cut in 1/3. All right, this distance again, cut in 1/3. And so measure those, cut them in 1/3, and draw the smaller figure here. The same things should be true, but you should be able to draw it using parallelism. So method 1 and method 2 do both of those. And then let's understand this concept of dilation as we refer to it in this notation, this transformation notation, like we had in Unit 3. And so with that, we kind of have to think a little bit about translations and reflections and rotations and glide reflections. And here, a dilation, we say a dilation is capital D, and then in parentheses, this subscript is K comma C, not for Kansas City, but K being the scale factor, the multiplier is usually referred to as the letter K in math classes, all right? They're usually, because it's some constant, and they have used C already, so they're not using C for constant, they're using K for a constant. And then C, capital C is your center of dilation. So here, the center of dilation was C, here the center of dilation was M, here the center of dilation was point R, all right? So, if I were to backtrack, I would call these a dilation of 1/3 about point M of triangle PQR. All right? That's the notation that we would use. If I backtrack to this, I would say that we have a dilation by a factor of 2 about center of dilation R of triangle JKL. All right? So you're going to see a lot of similar notation that we used in first semester. We're going to see that here with this notation. All right? Now, finding out what that scale factor is can be a challenge, but we also want to be able to classify if that multiplier is bigger than 1, we call that an enlargement. If it's between 0 and 1, that dilation is a reduction. All right? We are shrinking that figure down, whereas here we're making it larger. All right? But we need to make sure that all of our angles are congruent to our originals. So, let's think about these dilations. All right, what we want to do is analyze this to figure out what is our dilation. Here, I know that we are dilating by some amount. It's going to be a number bigger than 1, about point P. All right, of A, B, C, D is going to give us A prime, B prime, C prime, D prime. Now, to find out what that K value is, we are always going to compare, to find out what K is, we are always going to do new over old. All right? New over old. That's just a healthy way to remember things. And we can confirm and should confirm that it is a constant for each one of these. So K is going to equal A prime B prime over AB is the same as B prime C prime over BC, is the same as C prime D prime over CD, is the same as D prime A prime over DA. This should be the same ratio. It's not going to be the same numbers, but it's all going to simplify to be the same amount. So, since this is on graph paper, I can count. This is helpful because these are just vertical and horizontal lines. This is 2, 4, 6, 8, 9. So K is equal to 9 over 1, 2, 3. This one was a 2 across. 1, 2, 3, 4, 5, 6. There. This one, the same amount. We've already done that counting, and so I know that this is 9 and 3. And I know that DA, that's 6 units, and that's 2 units. All of these, if I simplify those, are equal to 3. So my k value is 3. All right, my dilation, 3 comma p of ABCD is equal to A prime, B prime, C prime, D prime. Writing that rule is huge. Identifying k is huge. Can you do that on letter B? You go ahead and try that. What are the side lengths? How are they related? How are the angle measures related, etc.? Answer those questions. Write out your dilation statement. All right. Find that k value and tell whether or not those angles are congruent or those side lengths are proportional. All right. Example 3. The scale factor is the ratio of the image to the pre-image. All right. The new over the old. The new over the old. So in this case, if I want to know my k value, I can simply compare these measurements. I don't have to have all 4 pairs of sides because if these are similar, if these are a dilation, then I know that these sides are proportional. So I can compare the new to the old. I can compare L prime K prime to LK. And in this case, we have 18 over 12, which simplifies to be 3 halves. So our scale factor is 3 halves, all right? If we know our scale factor, then that means that we can write our dilation. The dilation of, oh, I don't have this point labeled. Let's just call that point C. That's my bad, point C. The dilation by 3 halves about point C, that's center of dilations, of JKL, we'll start with J, JKLM gives us J prime, K prime, L prime, M prime. All right? The key here is, can we find that scale factor? Not super concerned about the notation today, but have that in your notes. We're going to use that for our next time class. And so the more that we can get that straight today, the better we'll be in our next phase. Example 3, you try. I would like for you to determine the scale factor, tell me if it's an enlargement or a reduction, and I want for you to write the dilation, I'll call it a statement or a rule, all right, that tells us how we got from our original pre-image is what that says, and then to our dilated image. All right? So tell me how we got from our original to our new figure. How did we do that? You go ahead and try this one to the best of your ability. Pause the video for however much time you need on that. And then the last part, and this is what we're going to spend some time working on in class. This is why you need graph paper today, because that's going to be really valuable for our work. So here we are given triangle ABC and the location of points A, B, and C in the coordinate plane. What are going to be the vertices if I dilate this by a factor of 3 about the origin? Okay, we are dilating in the coordinate plane. We're going to be dilating generally about the origin. That's our point of focus. And so from there, if this is our center of dilation, where are the new locations for A, B, and C going to be? Where is A prime, where is B prime, and where is C prime? Well, if we know our K value, here's how this works. A prime is going to be located at the original X times K, comma, the original Y times K. And so if we know that that K value is 3, then we can multiply those by 3. This is our K value. And so if we multiply by our K value, then we know that A prime is located at 6, comma, -3. We know that B prime, and we don't have to maybe write all this out, multiply by 3, multiply by 3, multiply by 3, multiply by 3. All right? If we multiply those by our scale factor, or our K value, our X and our Y, then we will have our new locations. Oops, that turned into gibberish. But here is what that would look like in X, comma, Y form. And then here's what it would look like in the picture. All right? That point C prime is now 3 times as far away from the origin. Point A is now 3 times as far. Here's 1, 2, 3 spaces, 3 times as far away from the origin. B is here, 2, 3 times as far away from the origin. All right, when we dilate by a factor of 3, that is what happens. All right, so we can calculate those pretty easily. We should be able to see it manifested in the graph and that's why we need to use our graph paper in our notes. I want for you to try this again on your graph paper. Our dilation factor is a fraction. I know that I'm giving you guys these hard ones, but you should be able to multiply by 1/4, either using your elementary arithmetic or your your calculator to multiply by 1/4. So give that a shot to the best of your ability. Pause the video as needed. That should kind of close us out for the night. Make sure that you come to class with a ruler. You need a ruler to do that work. We know that we're going to have some sheets to work on in class, but have some graph paper because I might have you do that graphing on a separate sheet. All right, please email with questions. That was a long one. I had to do a lot of drawing.